All right, ladies and gentlemen, we're going to go over this quiz word for word. So ladies and gentlemen, the first part of our quiz, number 1, we're going to balance this equation. We have to make the oxygens even. We have a 2 and 3 situation, so we're going to make them both 6. And then now we have 2 times 2 aluminums, which is 4. Okay, that's worth 3 points. Our next step here is now to look at the question. This says, when 5.6 moles of oxygen react. Okay, what that means is that oxygen is going to be our A. We are given that. How many grams of aluminum react? Our B is going to be aluminum. Okay, and what we're looking for here is grams, and this is moles. I could write it underneath like I've been doing, 5.67 moles, and this right here would be X grams. I know it's kind of complicated, but we have that. So ladies and gentlemen, the next step is, let's look at our mole map. I'm going to bring this mole map in here. Okay, it's a little lower. What type of problem do we have? Moles to grams. So I'm going to cover this up, moles to grams. How many steps of the truth table are there? 1, 2, 3. So I'm going to make 1, 2, 3. And then ladies and gentlemen, the next part's really easy. Mole of A. We're not going to put any numbers in. So we're just going to write mole, and what did we decide A was? Oh, it's oxygen, mole O2. Next one is mole B, so we'll write mole of aluminum. Cool. Then the next one is grams of aluminum. Boom. All right, cool. Now what about the bottom part? We just bring all of these down. So this is moles of O2, moles of aluminum. Now it's time to find the numbers. Okay, so the numbers are here, mole of O2. Well, they gave it to us, 5.67. Okay, now where you see you have a mole on top and a mole on bottom of 2 different things, that means it's a mole ratio. You get that from the balanced equation. So moles of aluminum from the balanced equation is the number 4. Moles of O2 from the balanced equation is the coefficient 3. Okay, now our next part is grams per mole. Well, that sounds like a molar mass to me. 1 mole of aluminum, well, where would I figure out the molar mass? Oh, I look at the periodic table. I look aluminum, it's 26.98. So I write 26.98 grams. When we do that, now we take out our calculator. Handy dandy calculator, ladies and gentlemen, and I know it'll be tough for you to see, but I take 5.67 and then I multiply it by 4, divide it by 3, and multiply it by 26.98. Come through and I get the answer 203 let's just do 0.97 grams aluminum. And I circle it, and all is well with the world. Okay? How about B? Now the next one is how many moles of aluminum oxide will be produced if 6.86 grams of aluminum react? So in this case, our A is going to be aluminum. Our B, what we're looking for, is going to be aluminum oxide, Al2O3. All right, let's not worry about the numbers other than we're given that we have grams and we need to go to moles. So a gram to mole problem, if we look at our mole map, gram to mole of B, well, that's only 3 parts of a truth table. So we set it up just like this. I'm going to move my calculator so you don't see that. And then we set up a 3-part truth table, and this goes on the top. Grams of, what did we decide was A? Oh yeah, A is aluminum. Then moles of aluminum, and then moles of, oh, what's B in this case? Oh, it's Al2O3. Well, now we have all those things there, but we do not have anything on the bottom, so it's really easy. We just move them down at a diagonal. So this is going to be grams of Al, and this is going to be moles of Al. So awesome. Now we can deal with our numbers. So how many grams of aluminum did they say in the problem? 6.86. 6.86. Now the next part is a molar mass, moles in grams. Well, the molar mass from the periodic table, 1 mole of aluminum, we just looked at that PT, and we've done it before, it's right here, is 26.98 grams. And then now our last part is a mole and a mole. That's a mole ratio. So we look at mole of aluminum, we look up here, that's 4. And mole of aluminum oxide, Al2O3, that's 2. So now we have all that. Now it's time to actually calculate. So I take my calculator, 6.86 divided by 26.98 times 2 divided by 4. I hit equals, and I get 0.127 mole Al2O3. All right, let's move on to the next one. So the next one here is another question where we have to balance the equation. So I have a 2 and a 3 again. Well, it's pretty simple. 2, 3, 2. Okay. Now next, this question says, when 0.72 moles of phosphorus reacts, I'm going to write it like this. Some of you may have seen it like this. 0.752 mole of phosphorus. How many moles of chlorine react? X mole. Guess what? This is a mole to mole problem. So look, mole to mole is simpler. 2 truth tables, or 2 sections. And when we do that 2 sections, the first one is going to be mole of A. What we have P, moles of P. The second one's going to be mole of Cl2 because that's what we're looking for. That's just on the top of the truth table. Then you bring this down, mole P. Now we add the numbers. Okay, they said we had 0.752 moles of phosphorus. Now we use the truth table, or use the balanced equation to get this mole ratio. So chlorine, the number is 3. And phosphorus, the number is 2. So we put a 2 there. We hit equals. We go 0.52 times 3 divided by 2, and that equals 1.128 mole Cl2. We circle it because that's responsible. That's all good. Let's see what the next problem says. The next problem says you have 8.89 grams of chlorine. Alright, here's that 8.89 grams of chlorine. That's going to be your A. How many grams of phosphorus trichloride? That's going to be your B, and it's a gram to gram problem. So if we look, it's going to have 1, 2, 3, 4 sections of a truth table. So I'm going to draw my line. 1, 2, 3, 4. Okay? And I'm just going to follow this. I'm not even going to put anything in number-wise. I'm going to write grams of A. G, and what is chlorine? Oh, it's Cl2. Don't forget that. That's what a lot of people forgot, Cl2. Then grams, and then now moles of A. So it's going to be moles of Cl2. Then the next one, it's going to be moles of B. And B is phosphorus trichloride, which is this stuff, PCl3. And then the last part is going to be grams of PCl3. So let's now move them over the diagonal so we get the second row. So grams of Cl2 go here, and then we're going to move this moles of Cl2 down here, and then moles of PCl3 down here. Now it's time to look up their numbers. This one told me my mass was 8.89 grams. Okay? So now this is a mole and a gram. This looks like a molar mass. 1 mole of Cl2, we take out the periodic table, we look up chlorine. Chlorine's right here, 35.45, but we have to multiply it by 2. So that's 70.9 grams. Now we have a mole and a mole situation. So we go back to the equation. How many moles of chlorine? That's a 3. How many moles of PCl3? That's a 2. And then our next section is grams and moles. That looks like a molar mass to me. So I know that 1 mole, and phosphorus is molar mass. I take out the periodic table to look it up. Phosphorus is 30.97. Okay, so I get out the calculator, and I go 30.97 plus 35.45 times 3. That 35.45 is the molar mass of chlorine. And that's 137.32 grams. So ladies and gentlemen, now we just do the math. We take the calculator, 8.89 divided by 70.9 times 2 divided by 3 times 137.32 equals 11.48 grams PCl3. We circle it. We're all responsible now. Cool. Alright, let's move on to the bottom. Alright, we're almost done. The next one, it says nitrogen gas reacts with hydrogen gas to produce ammonia. Here's what you needed to know. It's called Hunkelbrief. N2 plus H2. That's what people missed. Makes NH3. Once we have that, we have to balance it. Hydrogen is a 2 and a 3 situation. So we go like that. And there you go. That was worth 3 points. You need to know Hunkelbrief for the test. Now the next question says, if 75.2 grams of nitrogen, 75.2 grams, react with excess hydrogen, how many moles of ammonia are formed? X moles. This is a gram to mole problem, so it's only 3 sections of the truth table. So I'm going to start that right away. Okay, and grams of A, grams of what we're given. So we're going to write grams, and we're given N2. Then moles of N2. And then the next one is moles of what we're looking for. In this case, we're looking for NH3. Then we're going to fill out the bottom by just bringing these down. Grams of N2, moles of N2. Okay. So now we can put in the numbers. We start with 75.2 grams of N2. Well, the molar mass of N2 is 14.01 times 2, 28.02. That came from the periodic table. Now you have a mole and a mole situation, so that's a ratio. So you look for NH3, that's 2, and you look for N2, that's 1. Awesome. We're going to hit equals. I'll bring in the calculator. It's time for the calculator. 75.2 divided by 28.02 times 2. That is 5.37 moles NH3. Awesome. And ladies and gentlemen, we're almost done. Next one, it says write a balanced equation. Oh, this is where you actually have to use the back of your periodic table. Okay? This says ammonium sulfate. And guess what? There will be something like this on the test. Where do you figure out what ammonium is? Oh, ammonium. NH4 plus 1. And I'm just going to write it right up here. NH4 plus 1. Then it's sulfate. Oh, man, sulfate. It doesn't end in IDE, so it must be sulfate. Oh, there it is. SO4 minus 2. Remember your charges. You need to crisscross. So that becomes NH4 in parentheses 2SO4 plus calcium hypochlorite. Well, calcium we know is Ca. And since calcium is in column number 2, or Ca right there, that means it has a charge of plus 2. Hypochlorite, we haven't heard that one very often, but these are alphabetical, so here's hypochlorite. That's ClO, not Ci. ClO, and that whole thing has a charge of minus 1. So when we crisscross, that becomes Ca parentheses ClO2. Now, that's a double replacement. It makes ammonium hypochlorite. Well, NH4 over here is plus 1, and hypochlorite's minus 1, so they just kind of are squished together. NH4ClO plus calcium sulfate. Calcium's plus 2, sulfate's minus 2, so we're going to go CaSO4. Then, ladies and gentlemen, it becomes time to balance it. We have 2 ammoniums and 2 chlorites, the hypochlorite, so I'm going to put a 2 there, and then it is balanced. So now the next part, they're just asking you to find the ratios. So how many NH4 2SO4s? Well, there's nothing here, so it's 1. How many ammonium hypochlorites? There's 2, because of that number right there.